lesson on the sum to infinity. The sum of the first three terms in a geometric sequence is 124, and the sum to infinity is 125. So they've told us two things. They've told us a regular sum, like, for the finite geometric series, using the regular geometric series formula. They're told that sort of the first three terms is 124. They've also told us the sum to infinity is 125. They're pretty close to each other. Find the common ratio and the first term. So the one we know the most info about is the first one, the sum of the first three terms, because what would the n be for that?
3.
Yeah, 3, exactly. So we know what that is. So what we might want to do is write two formulas. I'll just check the calibration on this. I need to calibrate first, sorry. Oh gosh. Before we started recording. Big time on this. So let's undo that. Let's do a quick calibration. So what we're going to do is we're going to write a formula used for the sum to three terms, and we're going to write a formula for the sum to infinity. And then we're going to see what we can do with those two formulas. So at this point, if this was me in an exam, I'd look at this and feel a bit lost. So what I'd start to do is just write out any formulas I know and sub in anything I know, and then see if I can get inspiration from doing that. So for the first three terms, n is, as you said, n is 3. And they've said that the sum of 3 was 124. And for another one, over here, they said, they just said the sum to infinity equals 125. That's all we know for that one. And they want us to find the u of 1, and they want us to find the common ratio. So let's use our sum to infinity formula and our regular sum formula. Just reminding us, the regular sum formula is u of 1, but a little clue is, I'm going to use the other version of it, and I'll show you why very soon. I'm going to use the r to n minus 1 over r minus 1. Oh no, not that one. It's 1 minus r to the n, sorry. Remember how they give you two versions of it?
Mm-hmm.
And I'm going to use the other version, the 1 minus r to the n one, because when you do that, it's going to have the same denominator as the sum to infinity one. Because remember, the sum to infinity doesn't have r minus 1, it has 1 minus r. It's showing you that the sum to infinity equals u of 1 minus r. So I've chosen that particular version of the sum of a finite series, because see, when you do that, the denominators are the same. Both denominators will be 1 minus r. And I just chose to do that because I know this problem, so it's hard to say, okay, if I didn't know what this problem was going to be, what I would do. And then you'll probably see when you put some numbers in, you'll be able to sort of equate a few things and rearrange and solve for r. So let's start to do that with our blue one. Our sum to infinity in this case is 124 equals, we don't know what u of 1 is, so let's just leave u of 1, and then it's bracket 1 minus r to the n. We don't know what r is either, but we do know that n is 3 in this particular example, over 1 minus r. And again, we don't know what r is, so we just have to leave that in there. So we've just subbed in anything we know into that one.
How did you cancel it out?
Sort of. Like at this point, oh, I see what you mean, yeah. If this was exactly 1 minus r, like instead of 1 minus r cubed, then yeah, you're right, you could cancel that out. It's the fact that one's got an r cubed and one's got an r that we can't just cancel that out. But that's a good point. You want to start thinking things like that. Can I cancel something down so I can solve for u of 1? Let's also try subbing into this one, the sum to infinity over here. So the sum to infinity, that's the only bit of info they gave us. 125 is the sum to infinity, equals u of 1 over, and we still don't know what u of 1 is, and it's 1 minus r. And we still don't know what r is. So I would do that to sort of see, okay, there's similar looking formulas. How can I get some inspiration from that? So you notice that oh, I'll give you a chance to look at that. You know the denominators are the same.
See?
What's the only thing extra that the one on the left has? What's the only extra feature the one on the left has? Yeah, the bracket. Yeah, exactly. 1 minus r cubed. So we could almost say that this part, u of 1, 1 minus r, is equal to 125. So same with kind of this part here, u of 1 over 1 minus r. We can just set that equal to 125 and substitute it in. So we might want to sub in that u of 1, 1 minus r, equals 125. So again, sub that into here. So a bit like simultaneous equations in some sense, where you do a bit of substitution. Because u of 1 over 1 minus r appears in both of those formulas. So how could we write that? We could write 124 equals 125 multiplied by brackets 1 minus r cubed. So that's what we've done. We've sort of subbed the sum to infinity formula into the sum of a finite series kind of problem. And now do you see this makes it now possible for us to solve for r? Because the rest of the equation is just numbers. So we're going to actually be able to solve for r, which is lovely. And we can actually solve for r with that calculator too. So if it was with calc, we'd just go ahead and do it with calc. But where it can be done with calc, I like to I'd like to just show you how to do it. So when you start solving here, what would you start to do first?
Divide by 125.
Exactly, yeah. You divide by 125. That's the first thing you do. So 124 over 125 equals the rest of the stuff. Minus an r's of being 1 cubed. Cool. And then what might you do next? There's so many different ways. Would you want to make the r cubed positive first, or would you want to subtract 1 and then deal with divide off negative 1? My favourite thing to do is to make the thing you're looking for positive, but we want to find out what r is. So I'm going to prefer to instead add r cubed over here and subtract 124 over 125. That's my favourite way to do it. Just because you're not having to deal with the negative then. So r cubed equals, instead 1 minus 124 over 125. And that's just a little fraction. So do you see what I did there? I sort of like saving steps. Like I could have just first of all added r cubed to the left hand side, and then I could have subtracted the fraction on the right by bringing it sort of to some extent to the right side. But I just did 2 steps at once. Out of interest, what is 1 minus 124 over 125? Back to our fractions. That would be really... Oh, yeah, it is. I don't know where I was about to say, yeah, that's close, but no, it is. It's 1 over 125. And how did you get that?
Because you have to add 1 and you have to add 1 to 124 to get the whole number.
Yeah, that makes sense.
it
Yeah.
work.
Exactly, yeah. You have to add 1 to 124 to make it 125 over 125. If you weren't sure as well, you could also rewrite 1 as 125 over 125. Yeah. So that's just another way. But Krista's logic is good too. Like, you just need to add 1 more to the numerator to make it equal to 1. So r cubed equals 1 over 125. And what's awesome is notice that the top and bottom, the numerator and denominator, are both cube numbers. So we're going to be able to find their cube root.
Oh, okay.
So it's a nice one to be set up for non-calc. So this is going on forever, isn't it? The cube root, 1 over 125. And do you remember with your surds that you can kind of break up, or indices, you can break up the numerator and denominator and work out their cube roots separately? So it helps work like that. Cube root of 1 over cube root of 125, which equals 5, yes, but the space. Yep, 1 over 5. So R is 1 over 5. Yeah. Good. So we've found the R, and then it's good to look and think, have we finished? Or do they want something else? So we've found part of it. They want to find the common ratio and the first term. So the way you might want to find the first term is, so you know what R is. What's one of the formulas above here that we can just sub in R and solve for U of 1 really easily? Yeah, the infinity one's easier, isn't it? Yeah. You could have done it in the one on the left, but that's a bit of a drag. So this one, it's just going to be easy. See, sub in, what was the answer again? 1/5, or 0.2 in here, and solve for U of 1. That's what we're going to do. So do that anywhere you want on the side. If you need space, do it on the left here. So that's one answer. Let's settle it. Now on the side, we're going to now find U of 1, and we can use the 125. I'm just going to rewrite the formula we had at the top. Equals U of 1 over 1 minus R. And now we can sub stuff in. So 125 equals U of 1, 1 minus 1/5. What is 1 minus 1/5? 4/5 too. Yeah. So lots of practice about fractions going on here. U of 1 divided by 4/5. And to solve for U of 1, would you agree that we'd multiply both sides by 4/5? Because on this side it's divided by 4/5. Yeah, 125 multiplied by 4/5 equals U of 1. U of 1.
100.
You got 100? Yeah, sounds good, yeah. So you could do 125 times 4 divided by 5, or you can do 125 divided by 5 divided by 4. And 125 divided by 5 is 25. 25 times by 4 equals 100. So that was a bit of a tricky one. That's why I saved that one till the end. Are there any questions about that? That would be pretty hard in an exam. So as I said, the way you kind of get started is you just write out what you know. Write out any formulas you know and sub stuff in, and then maybe some inspiration comes to you. So if I first looked at this question, I even wouldn't realize what I was expected to do until I'd sort of started to experiment a bit. So that's sometimes how these problem solving questions are set up, that they just want you to write stuff out, sub things in. You might find something cancels down, or something simplifies, or something can be substituted into another formula. But you don't really see that. It's hard to realize that until you see these things kind of written down and near each other. So a bit of experimentation has to happen there. And now we're on to applications. Just word problems, as we said, word problems to do with maths. If you want, like, do you want to read through the careers in maths? I just feel like I need to.
Yeah.
But we do it after we've done the mathsy part.
Is anything funny?
No. Just showing you, like, talking about finance, basically. The fact that sequences and series kind of apply a lot to finance, which is a big industry in Bermuda. So if you work in anything to do with finance, you'll probably be dealing with sequences and series and trends and stuff like that. We can read through it at the end. We might do this at the very end too. That might be a good thing to do afterwards. We'll just get through the regular mathsy stuff first, because this one's more like an open discussion. Okay, so how can I work out what the question is asking is basically what you need to think of in these word problems. Like, from the question, is it an arithmetic sequence or a geometric one? And do they want us to find the nth term, or do they want us to find the sum? So if a particular thing is increasing or decreasing by a certain amount, not by a certain rate, like not by a percent, but by a certain fixed amount, like $5, then that of course means it's an arithmetic sequence. So an example of that would be when the international company opened up, it had 300 employees. The general director decided to increase the number of employees by 15 at the beginning of each year. So from that question, what's our common difference? 15, yeah. What's our U of 1?
300.
300, yeah, good. So it's good to interpret that. And of course it's arithmetic. Then they want us to say how many employees will the international company have during the 10th year? And do they want us to find the nth term or to find the sum?
The answer.
Yeah, just the nth term. Because the nth term is the total number of employees anyway. So the nth term happens to be, according to this question, it happens to be what the total number of employees are. And it's changing by 15 per year at the beginning of each year. Where's my answers to this? Cool. So, where are we? There we go. Right, yes, exactly. They want the U of 1. And so you might want to look back on your formulas and just write out your U of n formula. U of n formula, sorry. U of 1 plus n minus 1t. It helps write out these things. Yeah. I like to do that because sometimes if I don't, I end up plugging the wrong number in because I'm just not as focused. Yeah. So if we want the 10th year, n equals 10. So the U of 10, the U of 1, 100, plus 10 minus 1, 15. That could be a non-calc question, but it could just as easily be a calc. So feel free to use your calculator for that one. What's 9 times 15? Yeah, 135, hold on. What's 300 plus 135?
435.
Yeah, 435. So in terms of an answer, what we found there was the number of employees during the 10th year. And B, in which year will the company have more than 500 employees? What variable are they asking us to sort of calculate from here? N, yeah, they want to know the N first of all. So they want to know what the N is. Question mark. U of 1 and D are just the same. So if you want to write them out again, you can. If you don't want to, because they're already written down, no problem. What's our U of N? 500, good, yeah. So we're going to have to just solve for N. And this is not a horrible formula to solve with. It's a reasonably good one. So U of N is 500. U of 1 is 300. We don't know what N is. We know our D is 15. And then however you would like to solve that. It's probably up to you. You might want to expand first. You might want to track 300 first. 200 equals 15 N minus 15. So you feel free to solve it your way. And does anyone have an answer for N? It's a decimal. I got 14.3. That could be wrong. 14.3. Oh, nope, that's not the final answer, is it? Yeah. Sometimes I don't mind if you have an unrounded answer. Yeah, so in the 15th, yes, exactly. Because it's more than 500 employees. At the beginning of the 14th year, they won't have more. They'll have less than 500. What's that? So in the 15th year. 15. Yeah, sure. So that's a nice easy one. and so on. Okay. So as we said, the most difficult challenges with sequences and series, this topic, that's why it's in capital letters. So the most difficult challenges with these kind of questions in this unit is to decide whether they're asking for the U of n or the sum. Decide this first before proceeding with the question. Always write out the complete rule before commencing the problem. To be honest, you don't need to, but the complete rule with the variables substituted in there. You do need to show. Sometimes you do get a method mark. In SL, sometimes you get a method mark for writing the correct rule. Like, you know, that's occasionally, occasionally the mark scheme will say, give them a mark if they even thought to use a quadratic formula. So writing the rule is showing proof that you were thinking to use a quadratic formula. But quite often what they do want to see is the rule, but with the numbers subbed in. Before you do any maths with it, just with the numbers subbed into the original rule is what they like to see. The variables all subbed in, or the numbers subbed in, whatever. Okay. A market gardener plants cabbages in rows. These row kind of questions are classic word problems for sequences and series. The first row has 35 cabbages. The next has 39 cabbages. Each succeeding row has 4 more cabbages than the previous row. What kind of sequence is that? Good, yeah, arithmetic. What's our U of 1? Yep, and what's our D? Yep. You want to write arithmetic. Change colours. Good, yeah, U of 1 is 35. D is 4. Not much space to do our list, so I just did it up there. Calculate the number of cabbages in the 12th row. Do they want the U of n, or do they want the sum of U of n? Yeah, just sum of n, yeah. They just want to know how many cabbages are just in one particular row. So, of course, in that case, n equals 12. And they want the U of n. I'll write the formulas just so you can remember what they look like. They're in the formula booklet. I've just used them so many times I remember them. And then they want to know the 12th row. 12, 35, minus 1, minus 4. But you could do that one non-calc. So 12 minus 1 is 11. 11 times 4.
44.
Yep. And 35, sorry, plus 44.
70.
So there are 79 cabbages in that row. Fascinating. Which row would be the first to contain more than 200 cabbages? I'll be using the U of n formula or the sum formula still. U of n, yep. It's just talking about one particular row. Which row? So just a single row. So they want us to, which row number, what variable do they want us to find? N, yep, good. N. And they're saying that the U of n equals 200. So 200 equals, it's a bit boring actually because this one's similar to the last page. But at least the one down the bottom is a bit different. Classic mistake would be people would write 4n minus 1 by mistake. So just be aware of that. It helps draw those little rainbows. Minus 31. What is 200 minus 31? Because 35 minus 4 is 31. And then so we'd have to
If you wanted to, could you subtract 35 from it first?
yeah, you could totally do it in steps. What's that? 100 and
169.
yeah. If you solved a different way and you get the same answer, it's okay. We'll get a decimal, by the way. see my working out. Did you get something like 42.25?
Yeah.
And it is saying which row will have more than 200 cabbages? Will the 42nd row have more than 200?
No.
Yeah, it'll have just a bit less.
So the 43rd.
Yeah, that's it. 43rd row. So realizing that our n sort of has to be an integer is helpful here. The farmer plants only 945 cabbages. How many rows would he need? So what formula do we use for that? The sum or the U of n? Who guess?
And some.
It is the sum, yeah. They don't, it's hard to kind of like, why would it be the sum? Yeah, exactly. They're not asking about just one particular row this time. The previous ones, they were just asking about one particular row. So he's saying 945 cabbages in total. If they were going to be nice to you, they would give you a clue and write in total. Because the word in total tends to refer to using a sum formula. That's normally a clue that you're talking about the sum. How many rows would we need? Yeah, and so how many rows, therefore we're not particularly talking about a particular row. So they've told us that the S of n, is 945. The U of 1 is still the same as before. This happens, I'll just have to pause. You guys keep plugging it in if you want. And I'll just quickly pause. Okay, here we are again. So it's the sum of an arithmetic series. So we're not using the sum of a geometric formula, we're using sum for an arithmetic. So that sum formula. Do we know what the last, how many are in the last row? Like, do we know what the last term in the sequence is? Nah. So that way we can't use the shortened version, like we can't use Gauss's child version of the sum of an arithmetic sequence. We have to use the long version because we don't know what the last term is. Remember the short version, you just put brackets U of 1 plus U of n. We don't know what the U of n is, so we have to use the long version where we're subbed in the U of n formula. That big long one. We're going to end up solving for n. So there's got to be two spaces where the n will appear. So let's plug in the numbers. Get our method mark. N of 2, 2 plus 5, then we start to try to combine, expand, and do whatever we can. Expand that as well. If you want to solve in a different way, some of you might want to just go straight to doubling, get rid of the 2. It's okay too. I said a really common error is people wouldn't put 4 on the right, they would have done -1. That's a common error. I would suggest at some point to double both sides to get rid of the 2 in the fraction. So doubling both sides is a nice idea. What's 945 times 2?
5.
18.
How do you do that?
I'm just going to do double.
It's funny.
Double both sides to get that 2. What would you do from there?
If you could expand,
Yeah, expand is good. Expand works.
So it becomes a quadratic.
It doesn't it?
So you gotta subtract this and it equals 0.
Yeah. and then solve the quadratic. Good. So just like Krista said, our next step would be to turn it into a quadratic by setting it equal to 0.
Well, I'm not finding anything to add up.
Factor law.
So we're gonna have to do
Minus
everything.
1890. Let's see, is 4 a common factor? Doesn't seem to be. 2 is a common factor. If you wanted to make life easier, you could divide everything by 2 first. That'll make your number smaller. If it was non-calc, if it was calc, you could go straight to solving with polysmalls or whatever you have. If it was non-calc. 1890, is it a multiple of 4?
No.
Yeah, no, exactly, because 90 is not a multiple of 4. To be a multiple of 4, the last 2 digits have to be a multiple of 4. Is 66 a multiple of 4? No. Okay, so we can't just, but we could try halving it all, because they're at least in multiples of 2. This makes the equation a bit easier to deal with. So if you halve everything, you'll get 2n squared plus 33n minus, what was it again, 945? Then you could use quadratic formula if you had to use. Turns out you do get a whole number.
So we don't just put the middle thing, and then that would be irritating.
Yeah, you could do that. Yeah, it is pretty hard though, isn't
Yeah.
it? Like 2 times 945 and trying to find a number that multiplies to give that and adds to give the middle term. So in reality, because of that large number on the right, it would probably be a calculator problem. Does anyone want to try plugging it into polysmall or something like that to practice your polysmall? No? Let's try that. Solve using polysmall. You can also graph the quadratic and find its x-intercepts. That's what I recommend, just because it's an awkward quadratic to do by hand. And with the quadratic formula, it'd be a bit nasty too. So you could solve either version. It could be that one, or it could be that one. If you're using polysmall. The only reason I divided by 2 was to see if it was something that we could factorize easily. Or we might get a decimal answer actually. Just the final answer, because it's a number of rows, we have to make it a whole number, that's all.
Wait, it's gonna be the square root of a negative number.
Is it?
Unless I just did it wrong. Yeah, I did it wrong. Never mind.
Do you want a little demo of how to do it on polysmall? Or do you remember? Oh, people just not. Oh, clues were meant to get around 15. What's that?
15.
15 exactly?
Yes.
Okay. Did you get 2 answers?
Yes.
Yeah, what were the 2 answers? Because we don't know.
Negative 63 divided by 2.
Yep.
And 15.
So write both answers and then decide which one you reject. So, of course, which one do you end up rejecting? Yeah. So reject as we can't get the negative number of rows, and we'll accept 15 rows. So we'll write accept 15 rows. So to have 945 cabbages in total, and if they follow that kind of progression, like arithmetic progression, then he would need 15 rows.
Wait, I'm confused.
So the little question up here was, how many rows did he need to plant that many in total? So that's the tough thing, is working out, is it the U of n formula or is it the sum formula? That's probably the worst part of these questions. And the last one's that the maths is reasonably simple, but we're just doing some geometric word problems.
Wait, so what would be 2 values of x?
Our 2 values of x were 15, which is the one we accept, and the other one was negative 63 over 2, or as a decimal, like negative 31.5. And so you reject the negative answer because it doesn't make sense, and you accept the positive answer. I would suggest just writing both out, and then making this point of rejecting that and accepting this one. Now we're on to some different word problems. Okay. Examples. A microwave purchased for $540 depreciates. Do you remember depreciation?
An account.
Oh, you learned an account's good. What is depreciation?
Like just loses value.
Yeah, exactly. So if it depreciates good, you know that it's going down in value. That's important to know.
They go down.
Yep, exactly. So when it's depreciation, think of DE for decrease. So it depreciates at a rate. So if it depreciates at a rate, it's a geometric series of 8% per year. So if it's depreciating by or increasing by a certain percentage, that's a geometric. So I'm gonna.
Yeah, it's like you're dividing by a certain number.
Yeah, exactly. Yeah,
Okay.
or multiplying by a certain number. Yeah, exactly. So therefore, it is geometric. So those words there
Hello,
are
Sarah.
telling us
How
it's
are you?
geometric. Calculate its value in 3 years' time.
So basically, divided by 8 3 times.
Something like that. But we could use a geometric formula because that's a nice simple formula. Do you remember the U of n formula for geometric is just U of 1 r to the n minus 1. But you're right, you could technically also do it by hand because it's a short one. So you could do it manually. But we'll practice using the formula. U of n equals U of 1 multiplied by r to the power of n minus 1. And our U of 1, what's our U of 1?
540.
Good, yeah, 540. What's our n?
3.
3. Now what's interesting is what's our r? It's depreciating.
8.
Close. It's depreciating at a rate of, so compared to 100% means it's not changing at all. So what if it's depreciating at a rate of 8%, what percentage is it going down to? From 100?
92.
92, yeah. So what's 92 as a decimal?
0.92.
Yeah, 0.92. If it was,
You're multiplying it by 0.92.
yeah, because it's all relative to 100. Because timesing by 100% means that it's just staying at level. If it's increasing by 8%, it's going up from 100 up to 108%. So that would be 1 point. Oh wait, if it's decreasing by 8% from 100, it's going down to 92%. So 0.92. So it's all relative to 100%, and because it's going down to 92%, which is a thingamajiggy, as a decimal, it's 0.92. So that's how you work out those things, and then you just plug it in. You want to know the U of n. Question mark. So U of 3 equals 540. You can use the multiply sign if you want, or you can just go brackets 0.92. And it's 3 minus 1. In the calculator, some people go straight to just typing in 2. But you've got nice calculators that have the nice exponent box. So it's easy to type in 3 minus 1 if you want. And this would definitely be with calculator. Okay, it's a bit tough to do by hand. And you round, because it's money, we want to round our answers to 2 decimal places. And write a dollar sign. You get something like 400 something.
You don't think both? Okay, I haven't finished it. 0, 6.
Good answer. I could be wrong there. Did anyone get? You're probably right.
457, she said.
457. I got 420.49.
I got 457.
I think these are one of the tricky ones, where it's the fact that it's in 3 years' time.
Oh!
So I think maybe it's at the beginning of the 4th year then, is it?
I remember
That's what's
this.
difficult. Yeah, this is annoying, isn't it? In 3 years' time. And the geometric word problems are the really annoying ones, where sometimes you have to make the n a bit higher in the geometric problems. And it's all because it's 540. So then if it's gone down by 1, let's see. So you could test it manually. 540 times 0.92 would be what it would be after 1 year.
Yeah.
And then times 0.92
Yeah.
after 2 years. And times 0.92.
So shouldn't it be to the third then?
Yeah, to the power of 3 then, shouldn't it? Yeah, or like
2.
like at the beginning of the 4th year kind of thing.
So we tried to write it to the power of 2, but really it should be to the power of 3.
Yeah, to the power of 3, exactly.
So
Yeah.
we are then.
That's it. And because yeah, so how do we justify that? Do we either say just don't, we could say it's 4 minus 1, like at the beginning of the 4th year. So we want to, in a sense, find the u of 4 at the beginning of the 4th year. And then do you get the 420? Something? 420.49. And the proof was in just doing it manually at the top in 3 years' time. So it's at the beginning of the 4th year. And as I said, it tends to be the geometric word problems where these kind of things occur. So you kind of then have to think kind of, okay, how many times, if I did do it manually, how many times would I have had to have multiplied by 0.92? And that should be what the exponent ends up being. So we had to multiply, see in the manual one, we had to multiply by 0.923 times. So that's why our exponent had to be 3.
So Kevin, how do we put that as a note? Like, just so that we don't make that mistake.
Yeah, that's a good point. So beware in geometric problems. So beware in geometric word problems. One way you could think of it is the formula would just be r to the n instead, or you could say you need to add 1 to the number of years. Word problems, you need to.
So that formula is wrong.
Yeah, sometimes, yeah. Exactly 1 to the number of years. And in this case, because technically, it's meaning at the beginning of the 4th year. So at the beginning of the, so in 3 years' time, beginning of the 1st year, beginning of the 2nd year, beginning of the, no wait. Well, that, because that's at time 0, beginning after 1 year, after 2 years, after 3 years. The number of years, sometimes, maybe not always. Quite often when it's talking about the number of years, there's sometimes when you need to apply that kind of thing. It's irritating, but we've seen it come up a few times. By how much did it depreciate? So it went from 540 to 420. They just want to know how much did it change by. Perfect. Yeah. So 540 minus 420 is the little dollar sign. Just like Sarah said. Sorry, Sarah, for your name. 119.51. We're almost there. There you go. $5,000 is invested for 4 years at 7% per annum interest, compounded annually. Do you remember compound interest?
Yeah.
No? Okay. I think they give it to you in the formula booklet. I'm not sure. But it's similar to the depreciation. Per annum, yeah, per annum. Yeah, it's like Latin, isn't it? Like, is it? I think so, yeah, per year. It means per year. It's just a thing they say in banks. Per annum. What will it amount to at the end of this period? So compound interest formulas are like geometric sequences. And so if it's compound interest, is it increasing or decreasing the amount? Yeah, so it's increasing. So compound interest, that means it's geometric because it's increasing at a rate. What's that? You were 1. How much do we begin with?
500.
Yeah, 5,000. And they want to know what our R is. So it's increasing. What would be our rate? So going at 100% is going to mean it's not increasing.
1.07?
Yeah, 1.07, yeah. If it's increasing by 7%, it's going up to 107%, which as a decimal is 1.07. And it's compounded annually, so you don't have to worry about K's or anything like that. What will it amount to at the end of this period? So this is a tricky one. We might have to sub in n equals 4, or perhaps we need to sub in
n equals 5.
Yeah. Because meaning the beginning of the 5th year. So the beginning of the 5th year. Because if you did do it manually, it would be like saying, just showing you the demonstration of how you do it manually, 5,000. That's at time 0. So after 1 year, do that. Then after 2 years, do that. After 3 years, that. Hang on. 1 year, 2 years, 3 years, 4 years. Maybe we're right. Maybe it's just because then because the formula was n minus 1, so the exponent will have to be 4. So you could think of it as subbing in n equals 5 to the actual geometric sequence formula. This one here, right there. Or you could just think of making the exponent 4 instead. Whatever works for you. So it would be the u of n equals 5,000 times 1.07 to the power of 5 minus 1. Or you could just put just 4. That's okay, because you realise that this has to be multiplied by 4 times. And do you get something like 6,500 something? 9, 8. So just pause it.